Hey guys, welcome back to 13.2. In this video, we're just going to be sketching some angles in this first example. Might be all I'm doing in this video. Might be a short video. We'll see. So first of all, you always have the positive x-axis as your starting point. And then this is asking for a 36-degree angle. So I'm not asking for anything super specific, just a sketch. So it needs to be approximately right. So I know that 45 degrees goes straight up like this. It's halfway, right? So it's going to be along this line here. 36 is going to be less than that. So it doesn't need to be super accurate, just kind of right in between there. And then you have your little angle marker. And it'd be nice if that was a little bit curved. Kind of hard to do in such a small angle, but there you go. So that's a 36-degree angle. A 315-degree angle is going to be all the way over here in quadrant 4. And I know that because it's between 270 and 360. 270 is here, 360 is here. So I know I'm in quadrant 4, but where in quadrant 4 am I? To do that, I'm going to find the reference angle. So in quadrant 4, if you look back at the last video, in quadrant 4, to find the reference angle, I should say in quadrant 4, we have 360 minus the reference angle gives us our actual angle, which is 315. So to find the reference angle, I am going to subtract 315 from 360. So basically, I'm just rearranging this equation, right? If I add theta to this side and then subtract 315 to this side, I would get 360 minus 315 equals theta. So if you have to write that out, that's fine. But that's what's going to end up happening is 360 minus 315 to find my reference angle. So my reference angle is 45 degrees. Theta equals 45. So again, 45 degrees is halfway. So this one I actually can be very specific. I know I'm in quadrant 4 and I know it's a 45-degree angle. So that's going to be this line here. 45 degrees is basically the one where we can be the most specific because it goes right through. It's basically a line with a slope of 1 or -1. In this case, -1, but yeah. And then I need to draw my actual angle. And remember, this is positive 315, not -45. So we need to draw it going around this way. If you draw it going this way, that's wrong. That would be a -45-degree angle. Positive 315 goes this way. So that's that. And then -150. So -150 is going to be going in the negative direction, or clockwise, right? We're going to be going around this way. -150 is less than 1. It's between 90 and 180 in the negative direction. So -180 would be this, right? So -150 is going to be somewhere over here. And again, I want to figure out what my reference angle is. So if we remember from the last video, over here is 180 plus theta. Theta, yeah. And I'm just going to find with the, Because it's negative though, that's not as intuitive as it was over here. Because if I figured out what plus 80 was negative 150, it'd be a very big negative number, right? It'd be like negative 330, which is not what I want. So I want to figure out, so there are multiple ways I could think about this. I could either figure out what the positive version of this angle is, which I will talk about finding coterminal angles in the next slide. So I could just say, okay, I want to go, what would be the equivalent in the positive direction? I can do that and then use this formula, and that would be more straightforward. Or I could not use this formula and just think, okay, if this is 180, this is negative 180, and this is negative, and I want negative 150, what's the distance between negative 180 and negative 150? And I could just do 180 minus 150, and that would give me 30. So you can use these, basically these are for positive angles. If you have negative angles, you can find the positive version and then use these, or you can just logic it out, right? I know this is negative 180. I want negative 150. So what's the distance between those? It's going to have to be 30. So 30, again, is less than 45. So I'm going to just do something less than 45. This angle, right, is less than 45. This is the actual angle, right, which is the negative 150. And again, it's not super exact. It doesn't need to be, because it's sketching, right? Whenever we're sketching, that's like the less specific version. So that's how you sketch angles in standard position. Standard position basically just meaning it's coming off of the positive x-axis, which we're just going to be assuming that everything is, because that's how we measure angles on a graph like this. So just assume that everything is standard position. All right, so that's that, and I will see. I'll see you guys in the next video. Let me know if you have any questions.